Welcome. We're going to be talking about trapezoids and kites again in this video, and really, we talked about trapezoids in our previous video for section 8.5, and now we're going to be focusing on kites and the properties of kites. So what is a kite? What are the properties for the sides, the angles, and the diagonals of a kite? Well, let's get into what a kite is right off the bat. A kite geometrically looks an awful lot like the kite that you would fly. Alright, you recognize this shape right here, I believe. If we just had a little string attached to it right there, some wooden slats to hold it together, you could take this thing out for a flight, couldn't you? But geometrically, there's a very simple definition for what a kite is. Alright, and that definition is simply this. A kite is going to be a quadrilateral in which two pairs of consecutive sides are congruent. So here's one pair of consecutive sides that are congruent. Here's another pair of consecutive sides that are congruent. So rather than the opposite sides being congruent in a pair, like in a parallelogram, the consecutive sides, two different pairs of them, are congruent in a kite. Now, one thing that's very important is that not all four sides can be congruent in a kite. We cannot call a rhombus or a square a kite, in other words. They have similarities to a kite, but, well, I think you got the idea of what a kite is at this point. Let's write the definition down. And here is that definition that states what I've been saying. A kite is a quadrilateral in which two pairs of consecutive sides are congruent, but opposite sides are not congruent. Well, let's talk about properties of kites then. And really, in order to understand the properties of kites, there's one simple thing you need to understand about kites, and that is that they have symmetry. You can draw exactly one line of symmetry in any kite. And so in these kites, I think you can tell that the line of symmetry would be the longer of the two diagonals right there. Now I'll come back to that idea of symmetry momentarily. Now we've already stated the properties that you need to know about the sides of a kite, and that's that the two pairs of consecutive sides are congruent and the opposite sides are not congruent. And that symmetry kind of bears that out. Since I'm telling you that this diagonal is a line of symmetry, it makes sense that these two sides will be congruent to one another, and these two sides will be congruent to one another. And then you just have to know by definition that the opposite sides are not congruent. Okay? If the opposite sides were also congruent, here you would have two lines of symmetry. You're only supposed to have one line of symmetry in a kite. Alright, well, what about the angles in a kite? Well, if I draw that line of symmetry again, what you ought to see is that there's one pair of angles in a kite that are going to be congruent to each other. One pair of opposite angles, in fact, and can't you tell that it would be this pair of opposite angles? Now, these two angles are not going to be the same, the ones at the end of the line of symmetry, but the opposite angles on either side of the line of symmetry are always going to be congruent to one another. And then you might remember a property about the diagonals of a rhombus in which each diagonal bisects a pair of opposite angles. Well, the line of symmetry here does that in a kite, although the other diagonal does not. There's exactly one diagonal in a kite that bisects a pair of opposite angles. Alright? I guess I should actually write that down in the diagonals part, shouldn't I? So let's draw the line of symmetry in this last picture. And what I'm telling you is that that diagonal bisects this pair of opposite angles. Those two angles are congruent, and those two angles are congruent to one another. Alright, and one other thing that you need to know about the diagonals, and this will require me to draw the other one. Yeah, and this is not a perfectly drawn kite, but you'll kind of get the idea. The diagonals of a kite, like the diagonals of a rhombus, are perpendicular to one another every time. If they weren't, then the symmetry that I've described to you along this line of symmetry wouldn't work out, because there's no way this angle and this angle could be congruent if they weren't right angles. Okay, so the diagonals are perpendicular, and the longer diagonal, the line of symmetry, bisects a pair of opposite angles. These are the properties that you need to know about kites. Let's work through just a couple of examples in order to see how you apply those properties. In this one, we're going to be working with the angles, and I'm wanting you to find the values of x and y, given that this quadrilateral CDEF is a kite. Okay. Well, there are two facts about the angles of a kite that we're going to have to use right here. And you might say I only told you one property about the angles of a kite, and that's true, but there is a second fact that we're going to utilize momentarily. Let's utilize the fact that I told you in this video so far, and that's that you have exactly one pair of opposite angles that are congruent within a kite. And you can pretty much always visualize which of those are because you can visualize where the line of symmetry is, right? If I draw the diagonal DF, that's going to be the line of symmetry for the kite, meaning that angle C and angle E are going to be congruent angles. Now I'm going to erase that diagonal so that it's not in the way for the next thing that we're going to do. But you can see angle C is congruent to angle E. So we're going to say 88 equals 2x minus 12 and go from there. Alright, so we're going to have 100 equals 2x. X then is going to be equal to 50. Now, the other angles are not congruent to one another, the other pair of opposite angles. Angle D is not congruent to angle F. So we can't set x plus 4y equal to 60. That's not true. I'll just write that out. X plus 4y cannot be equal to 60. If it were, then both pairs of opposite angles would be congruent, and this would be a parallelogram instead of a kite. And I hope that's pretty clear from looking at the picture that this is not a parallelogram. I wasn't trying to draw this one off scale. It's supposed to be drawn to scale. So, how do we make an equation then that helps us find the measure of this angle D right there? Well, the other fact that we need to know is simply the sum of the interior angles of a quadrilateral is 360 degrees, right? So, the measures of angles C, D, E, and F combined is 360. Now, follow along with me because I'm about to do some mental math. What we're going to do is we're going to go ahead and add the angle measures together, and we're going to combine the like terms mentally whenever we do that. So we're going to start with, we have an x here and a 2x there, so that means we'll have 3 x's in total when we add the angles together. We've got 4y there, and that's the only place where we've got a y. And then we've got constant values to add. We've got the 88 plus the 60, that's 148. And then we've got the minus 12. 148 minus 12 is positive 136. So I can say that 3x plus 4y plus 136 is the sum of the interior angles, and that has to be equal to 360. And this equation wouldn't do us any good if we didn't know either x nor y, but we do know the value of x is 50, so let's go ahead and substitute then. 3 times 150 plus 4y plus 136 equals 360. Then we'll combine our like terms and we'll say then that 4y plus, now this is going to be 450 plus 136. Whoops, I already did the multiplication when I substituted accidentally, didn't I? That's supposed to be 3 times 50. So 150 plus 136 is 286. And so then we'll get 4y equals 74, is that right? And then y is going to be equal to 18.5 then. Alright, so the one pair of opposite angles is congruent, and the sum of the interior angles of a kite, just like any quadrilateral, is 360 degrees. That's how we solve that problem. One more problem we're going to look at here. This time, we're going to find the lengths of the sides of a kite. Now, I've given you the lengths of the diagonals, essentially, and then we're going to try to find the length of QR, RS, ST, as well as QT. Now, how are we going to find the lengths of the sides using the diagonals? Well, we're going to use one of the two facts that I told you about the diagonals of a kite, and that is that the diagonals are perpendicular to one another, so here's a right angle, which means that each of these 4 triangles that you see here are right triangles. So, also, you can tell because of the symmetry that RS is going to be congruent to ST, and that QR is going to be congruent to QT, right? So really, we're going to find RS using this triangle, RS, whatever that point is, and then we can find QR using triangle QR and whatever the intersection of the diagonals is, and then we'll know the length of all the sides. Let's go ahead and find the length of RS first. Using Pythagorean theorem, you can see that RS squared would equal 10 squared plus 12 squared. So that's 100 plus 144. So RS squared is equal to 244. And then RS would be the square root of 244. And we're going to go ahead and leave this as an exact value in simplified radical form. So let's think about what's a perfect square that's a factor of 244. Well, it turns out 4 is the only one that I can think of. It's the only one, actually. We can make that the square root of 4 times the square root of 61, or 2 square root of 61. Okay? Then we'll do the similar thing to, let's go ahead and say that TS also equals 2 square root of 61. Okay, because we want to find the length of all the sides. Now similarly, we can make this equation to find QR. QR squared is going to equal 10 squared plus 20 squared, so 100 plus 400. So QR then is going to end up being the square root of 500. And we're going to write this as a radical in simplest form as well. The largest perfect square that you can factor out of 500 is going to be 100. We can make that the square root of 100 times the square root of 5. And so that becomes 10 square root of 5. That's the length of QR. That's also the length of QT. We found the lengths of the sides of that kite using the lengths of the diagonals. Great. That's all there is to kites, really. You just have to know that it's symmetrical and the few basic properties that I told you about their sides, angles, and diagonals. Alright guys, thanks for your attention. Good luck with all these problems. Later.